So hello everyone, I am Yujing, a PhD candidate in Phil University, the Department of Spatial Economics. And now I wanted to introduce my research about spatio-temporal dynamics of urban ecosystem services, supply-demand mismatches, a case study of Amsterdam. So first of all, let's zoom into the importance of the balance between ecosystem services supply and demand, which is really important for urban planners and designers. Because as we all know, as the urbanization develops continuously, so it is quite important to make sure the balance between services supplied by ecosystems and the services demanded by the society. And it is also quite important to make them in a uniform unit. And then we can get the match states, which is the delivered part and the desired part. Then we get the reality. So that is the situation here, so we can focus on. And my research is mainly focused on in situ ecosystem services, so recreation service and cooling service. Why we focus on those kind of services? As we all know that the ecosystem services can be classified to three main ecosystem services, and most of them can be transported from one location to another, right? However, most cultural services and regulation services cannot be transported, and most of them should be consumed in situ. So that's why they are quite important. And I picked each service from each of them, recreation service from cultural services, and cooling service from regulation services. Those two services are quite important for residents' physical and psychological health, and they have to be, consumed in situ in their neighborhood green spaces. So that is really important for us to focus on those. Here is the first service, the recreation service match, which we mapped. And the method is we want to make the supply part and demand part in a uniform unit. Then we can get the match situation between supply and demand. And for the supply, we used a cell which is 500 meters by 500 meters. And this is a quite important cell for a small neighborhood because it is like a walkable distance, a reachable distance for residents to go outside for their recreation, daily recreation, right? So we use this cell as our basic unit. And in each cell, and we measured the area of green spaces as our supply, and the demand is how many people there, and we use 9 square meters for per person as our demand. So we get the demand from the people, residents in each cell, and the supply minus demand, we get the match. So if the match is negative, it means that is there is some demand are not being satisfied by the supply. So here should be some problem we should focus on. And we can see the map on the right hand, and we can zoom into the difference between 2000 and 2015, right? So the recreation services match condition in Amsterdam there for are mapped there, and we zoom into different the changes between them, and we can get where we wanted to give some advices or suggestions to our planners. Because we don't, as the photos shown there, and we really want a place, a green spaces with how to say, a really huge space people can enjoy, and we don't really want to be in a crowded places with so many people, and you cannot pick a spot for your recreation, for your lunch, right? So that's why we focus it firstly, and then we move on to the another service. Uh, it is the cooling service, and uh, the cooling service we use a tool as the tool is urban heat island intensity. So for the supply, we 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 use the urban heat island intensity, which is cooled down by the green species, and then we multiplied it by the people in each cell, the population in each cell. So this is our supply, and the demand, we assume that people really want to get the advantage of the city neighborhood, but they do not really enjoy the urban island effect, right? So they prefer to have a temperature as a rural area, even though they live in an urban area. So that's their demand, their desire. So we measured the demand as urban heat island intensity, the total urban heat island intensity without any cooling effect, without any green spaces or, and we multiplied it by the population, then we get the demand. So supply minus demand, we therefore get the match. So as we can see from the maps, we mapped the match in 2000 and 2015, and we can get the changes between those 2 years, and we zoom in, we can find what is happening there, and we can use it as a suggestion, as a tool for our urban planners, right? Okay. So both services are also calculated in our urban-rural gradient. So they are calculated as match area proportion from urban area to rural area. And as we can say, the match situation, the curve increase from urban area to rural area, both in 2000 and 2015. However, there's a change between those 2 years. Both services turn worse in urban areas, which you can see on the left-hand side, right? So it get worse, and from we can see from the right-hand side, in the situation get better from 2000 to 2015 in rural areas, which also means something happening there, right? So this is what we want to know. We want to mirror the ecosystem services supply and demand in a really uniform unit, where with which we can get the match situation between them, and we can give suggestions to policymakers or urban planners. And yeah, that is our research mainly focus on that. And the next steps and further discussion are in progress. So first of all, the cooling service in a more straight-away unit is also our next focus for the next paper. And the other is the intern comparison in monetary value, which can make it possible for different services with a uniform unit. So it's a unit to compare, so we can get which services are more important for people or less important for people. Uh, so that is what we have done for this research. Thanks for all your attention, and welcome to all kinds of questions and suggestions. And you can also reach me by email after this webinar.